This question is no longer on binary operation, but on integration. So I'm going to be taking the next 10 questions on integration. And the first question we are going to consider under this integration is integral of pi over 4 and integral of pi over 12, 2 cos 2x dx. This type of integral, and the one you are most likely to come across, will be definite integral. This one is definite integral because it has its lower bound and as well its upper bound. It is bounded below and it is also bounded above. So how do we integrate it? We let these two being a constant out of the integral sign to give us this. And you have pi over 12 and pi over 4. In the context of this evaluation, our pi is not 3.142 or 22 over 7. Pi in this context is 180. So we have this one as 2 integral of pi over 180 over 4 is 180 over 4. 180 over 4 is 45. And this one is 15 cos 2x dx. We proceed to apply the method of substitution to integrate this. We let u equal to 2x and our du dx is equal to 2, in which our dx is equal to du over 2. What are we trying to do here? We want to have a complete transformation of variable from x to u. So I will substitute anywhere I see x, anywhere I see 2x, I'm going to put u, and anywhere I have the x, I'm going to put the u over 2. So this one is going to give us cos u, and dx is now du over 2. These two, we cancel these two because it will be let out of the integral sign as 1 over 2. So you are now left with integral of 15 cos u du. When you integrate cos u, you have sin x. But if you integrate cos u, you have minus sin u. I want to say it again, that when you integrate cos u, you have sin u. But when you differentiate cos u, you have minus sin u. That is just a standard integral. So this one is going to be sin u 15 to 45. But my u is 2x. I will now put it as sin 2x 15 to 45. So from here, I can substitute that this one will give me sine into 245 minus sine 2 into 15. This one will give me sine 90 minus sine 30. Sine 90 is 1, and sine 30, as you all know, is 1 over 2. So the result to this evaluation is 1 over 2. Therefore, integral of pi over 4, pi over 12, 2 cos 2x dx is equal to 1 over 2. So the correct option there is C, which is 1 over 2. We move to the next question. In this example, we want to integrate 1 minus x over x cubed. How do we proceed to integrate it? We introduce our integral sign and write the integrand. The integrand is 1 minus x over x cubed. Then we introduce the x, since we are integrating with respect to x according to the question. We split this into 1 over x cubed minus x over x cubed. Then Upon reducing it into the least fraction in the second term, we can rewrite it as x raised to power minus 3 minus x raised to power minus 2. Don't forget that this x must have cancelled this one and reduce it to 2. Everything dx. We integrate the individual term. This one is integrated as x raised to power minus 3 plus 1 over minus 3 plus 1. And this one is going to be x raised to power minus 2 plus 1 over minus 2 plus 1. So we have this one as x raised to power minus 2 over minus 2 minus x raised to power minus 1 over minus 1. So we have this one plus c or k as the case may be. So this one is going to be minus 1 over 2x squared plus 1 over x plus k. This thing can be written as 1 over x minus 1 over 2x squared plus k. The correct option to this integral is 1 over x minus 1 over 2x squared plus k, and that is in option C. This is another definite integral because it has the lower and the upper bound. Minus 1 to 1 of 2x plus 1 squared dx. So, to integrate this one, we can let u equal to 2x plus 1 so that du dx is equal to d dx of 2x plus 1. So this one will give us 2. Because if you integrate 2x, what you have is 2. If you differentiate 2x, what you have is 2. And if you differentiate a constant, you have 0. This one is plus 0, which doesn't make any difference. Therefore, du dx is equal to 2, and our dx is equal to du over 2. We substitute. We have integral of minus 1 to 1 of u squared du over 2. We bring out 1 over 2 out of the integral sign, then we integrate u squared du with respect to the lower and upper boundaries. We have this one as 1 over 2 u raised to power 3 over 3 1 to minus 1. So we have this one as 1 u cubed over 6, then minus 1 to 1. We put our u here as 2x plus 1 raised to power 3 over 6, 1 minus 1 to 1. So we are now going to substitute the upper and the lower boundaries to have our numerical value. You subtract this, the value of x at the lower region from the value of x at the upper region. So you put x equal to 1 first. It becomes 2 into 1 plus 1. Everything raised to power 3 over 6 minus 2 into minus 1 plus 1. Everything raised to power 3 over 6. So this one, we have this one as 2 times 1, which is 2 plus 1, that is 3. 3 raised to power 3 is 27. So we have 27 over 6 minus this one is 2 times 1, which is 2 times minus 1, which is minus 1. Then 2 times minus 1, is minus 2. Minus 2 plus 1 is now minus 1. The result of this particular one is minus 1. Minus 1 cube. Minus 1 cube over 6. So we're going to have this one as 27 over 6 plus 1 over 6. The LCM is 6, and we have this one as 28. We can reduce to the least fraction. 2 goes here, 3. 2 goes here, 14. And you can also write it as how many times does 3 goes in 14. 3 goes in 14 4 times. The remainder is 2 and you have 3. It implies that one of the reduced form of the options is 4 whole number 2 over 3, which is option D. We want to integrate 1 over x plus cos x. 1 over x plus cos x is another indefinite integral because it is not bounded below, neither is it bounded above. We integrate the individual term as this plus integral of cos x dx. Whenever you integrate the reciprocal of x, you have ln x. Then if you integrate cos x, what you have straight away is sin x. Then we add the constant of integration, which can either be k or c. So in this case, the correct option is, we are moving to the next question, which is question number 24. Question number 24 is given to be, if y equal to x into x raised to power 4 plus x squared plus 1, we are required to evaluate. You have to evaluate integral from -1 to 1 of y dx. You substitute for y here, but before then, it is good that we expand this particular bracket so that we have y equal to x raised to power 5 plus x raised to power 3 plus x. Then we substitute and integrate y dx from -1 to 1 as integral of x squared x raised to power 5 plus x cubed plus x. This one is -1 to 1. Obviously, the result of this is most likely to be 0. But let us inspect it. If I integrate individual term, I'm going to have x raised to power 6 over 6 plus x raised to power 4 over 4 plus x raised to power 2 over 2 from -1 to 1. So I will substitute the value of x equal to 1 and equally substitute it equal to -1. So I will have this one as 1 over 6 plus 1 over 4 plus 1 over 2 minus this one is -1 raised to power 6 is still 1 over 6 plus -1 raised to power 4 is still 1 over 4. -1 raised to power 2 is 1 over 2 because whenever the power is even, regardless of the number, if a negative number is raised to an even power, the result is always positive. So in this case, this will cancel out this and the result is going to be 0, and that is in option D. The next one we move to is question number 25. This 25 is on integration, but a definite integral. We integrate 0 to pi of cos square theta minus 1 over sine square theta. According to the identity, you should know that cos square theta plus sine square theta is equal to 1 because this is the most popular identity under trigonometry. We make cos theta the subject of the formula. It becomes cos square theta equal to 1 minus sine square theta. Therefore, anywhere I see cos square theta in the integrand, I substitute 1 minus sine square theta for it. It's now going to be 0 to pi of 1 minus sine square theta minus 1 over sine square theta. Minus 1 will cancel out, plus 1 here. And this minus this sine square theta will cancel sine square theta. I will only have integral of 0 to pi of minus the theta. So from here, I'm going to integrate the theta as follows. This will give me minus integral of 0 to pi of the theta. Then integrating the theta, I will have theta into 0 pi in this form. So this one will give me minus pi minus 0, which is equal to minus pi. The correct answer to this question is minus pi, and it is in option D. All right, the next question is question number 26, and it is still on integration. The question is still on integration, and that is number 26. We are required to integrate 2 into 2x minus 3 raised to power 2 over 3 dx. In this case, we let these two outside the integral sign as this. The x will now integrate this function. We let u equal to 2x minus 3 so that the u is equal to 2 dx. And in this case, my dx is equal to du over 2. I will substitute for both u and the x to change this from variable x to variable u. This one is now 2 integral of u 2 over 3. The u is 2, is the u. The x is the u over 2. We have this one to take care of this. So integral of u raised to power 2 over 3 du will now be integrated. This one is done by adding 1 to the existing power and make it this plus 1, everything plus c. So from here, we can see that this one will become u raised to power 5 over 3 over 5 over 3 plus c. And this one will give us u raised to power 5 over 3 divided by 5 over 3. Then, from here, we have it as u raised to power 5 over 3 times 3 over 5. Our u is 2x minus 3. Therefore, this particular last expression will now become 2x minus 3 raised to power 5 over 3 times 3 over 5, which can now be written as 3 over 5 into 2x minus 3 raised to power 5 over 3 plus the constant c. So the option here is option C, which is 3 over 5 into 2x minus 3 raised to power 5 over 3 plus c or k, as the case may be. We proceed to the next question. The next question is still on integration. We are required to evaluate integral of sine 3x. We want to integrate integral of sine 3x. Integral of sine 3x dx. This one is going to be integrated by substitution. We let u equal to 3x, then if u is equal to 3x, du dx is equal to 3. Because when you differentiate 3x, what you have is 3. You substitute by making the x equal to the u over 3. You substitute respectively. The integrand now become sine u dx is du over 3. Therefore, we have this one as 1 over 3 integral of sine u du. When you integrate sine u, you have minus cos u. The answer, therefore, is 1 over 3 minus cos u plus c, which is minus 1 over 3 cos. Since our u is 3x, we substitute it. We have the answer. So if you study the option, you will understand that the correct option here is minus 1 over 3 cos 3x, and that is option A. We move on. Question number 28 is still on definite integral. We are integrating x squared minus 2x dx between 2 and 3. So we have integral of 2 to 3 of x squared minus 2x dx. As it is here, we are going to integrate individual term, and it's going to be integral of x squared minus integral of 2x dx dx. The limit of the two is 2 to 3. So this one is going to be x cubed over 3 minus 2x squared over 2. 2 to 3. This one will take care of this, and I have it as x cubed over 3 minus x squared between 2 to 3. I will substitute. This is 3 cubed over 3 minus 3 squared minus, open bracket, 2 cubed over 3 minus 2 squared. This one will give me 27 over 3, which is 9. And this is also 9. This one will go, it becomes 0, minus, what I have here is 27 over, is 8 over 3 minus 4. This one will give us, the LCM of this one is 3, and this is 8 minus, this one will give us 1 goes in 3 is 3, and this one will be 12. Therefore, we have this one as equal to minus into minus 4 over 3, which is equal to 4 over 3. This 4 over 3 is the correct option, but there are instances that it will be expressed as a mixed fraction, and you have it as one whole number 1 over 3. So the correct option here is option D, which is 4 over 3. Question number 29 is still the same thing as that. From here, we will integrate 1 to 3 of x squared minus 1 dx. If we want to integrate this one, we will follow this previous pattern. And this one will give us x raised to power 3 over 3 minus x. Because if you integrate minus 1, it's like you're integrating minus dx. So you have x, then this one is going to be 1 to 3. You substitute the value as 3 cubed over 3 minus 1 cubed over 3 minus 1. This one will give me 27 over 3 is 9. 9 minus 3 is 6. Therefore, 6 minus 1 over 3 minus 1. 1 over 3 minus 1 is, this is 3, and 1 minus 1 goes in 3 is 3. 3 times 1 is 3. So you have this one as 6 minus 2 over 3 is equal to 6 plus 2 over 3. The LCM is 3, and what you have here is 18 plus 2, which is 20 over 3. Looking at this one, we can present the answer in the simplest form as 3 odd number, as how many times does 3 goes in 20? It goes 6 times. The remainder is 2 over 3. So the correct option is 6 whole number 2 over 3, which is in option A. The next one is still on definite integral. On this one, you have integral of 0 to pi over 2 sine 2x dx. Integrating this one, you have to let u equal to 2x. If u is equal to 2x, then du is equal to 2 dx. And in this case, your dx is equal to du over 2. We substitute respectively as 0 to pi over 2 sine u dot du over 2. We let out 1 over 2, the integral sign. 1 over 2, integral of pi over 2, 0, then sine u. If you integrate sine u, what you have is minus cos u. So from here, you have this one as 1 over 2 minus cos u, 0 to pi over 2. Now, since our u is 2x, since u is 2x, we proceed to have this as minus 1 over 2 cos 2x, 0 to pi over 2. Like I said earlier, our pi is not the usual 3.142 or 22 over 7. Pi here is 180. Therefore, is substituting this 2x into 0 and pi over 2 is 90. Because 180 over 2 is 90. You now have minus 1 over 2 cos into 180. Cos into 180 minus 1 over 2 into cos 2, 0. From here, I'm going to have minus 1 over 2 cos 180 is minus 1, whereas cos 0 is 1. We have plus 1 over 2 times 1. So this one will give us minus half plus, this is half plus half. The answer is equal to 1. So the correct option here is 1, which is option A.